In this video, we're going to talk about interest, and we're going to look at three different formulas for interest. The first one being simple interest, which is something that you learned back in pre-algebra days. I equals PRT should ring a bell. I stands for interest, P stands for principal amount, R stands for interest rate, and that's converted to decimal, T stands for time, and that's in years. The next formula shows us how we can find the amount earned with the principal and the interest together. Back in the pre-algebra days, we usually just found the interest and then added it back into the principal to find the amount. Well, what this formula does, it kind of takes those two steps and puts it into one. So if you follow along with the line of reasoning here, you'll see that you have the amount earned is equal to the principal plus interest. The principal is equal to PRT, so we're going to rewrite that. Take out the I and plug in the PRT. And next we have a common factor of P in both of these terms, and so we can factor it out. When we factor out a P from a P, we get a 1 plus RT. And that gives us a neat little formula that we can find the amount in after a certain amount of time. The next formula is compound interest. Compound interest is a little bit different in that we are going to just take the interest more than one time in a year. We're going to take it maybe monthly or weekly or annually. We could take it annually. We could take it quarterly. So those are the things that compound interest involves. You'll notice that the formula is very familiar to the simple interest formula in that it does have one extra variable, and that is the letter N. But let's just take a look at A. Stands for the amount earned, P stands for principal, R is the rate and converted to decimal, T stands for time in years. So N represents the number of times per year that the interest is compounded. So for example, if it's quarterly, it's going to be 4 times a year, so N would be 4. The next and last formula is the compound continuously. And this is brand new. We just learned about the number E, and it's an irrational number, we know, but we've never looked at it in an application, so this will be our first application. Once again, we should see some familiarity. A stands for the amount earned, P is the principal, R is the rate converted to a decimal, and T is time in years. So actually this is a little bit more simple than the compound interest formula, because you don't have to worry so much about order of operations, which let me just go back and revisit that for a sec. Well, I'll do that in the next section. Yeah. This is an example using all three of those formulas, and so we see that we have $500, that's our principal, and 4% is the rate, and 3 is the time in years. So when we use each of these formulas, we're going to plug those in, and again you can see the progression of this formula. When it's done annually, it's one time a year. You plug those in and you can see that this is the answer. Now notice, I want you to notice something real important here, in that when you have this formula, you want to make sure that you do what's inside the parentheses first, because if you distribute the 500, you're going to get a incorrect answer, and that is a very common mistake. So do what's inside the parentheses first, raise it to the third power, and then the last thing you want to do is multiply by 500. In like manner, the same is true for this one. If this is done monthly, then N is equal to 12. That's the only difference in this formula and this formula, you see, is that addition of the number 12, and you see it in these two places, and again the answer is given over here on the far right. And finally, compounded continuously, you see that the amount earned is equal to the principal times E raised to the 3 times 0.04 power. And again, this one is probably the easiest of the three, again, as I mentioned earlier, because you don't have to worry about that order of operations. You just do it. Alright, you'll notice also that there's a very little difference between these amounts. So you might be asking, why bother? Well, this is a small amount of money over a short amount of time, and that's the reason. When you start adding money and adding years, it begins to make a significant difference. Here's another example. We have invested principal amount of 800, so that's going to be P, and R is going to equal 5%, and T is going to be equal to 6. And you can see, because we are compounding it daily, we're going to use the compound interest formula. So again, when we plug these values in, remembering to work what's out inside the parentheses first, raising it to this power, and then multiplying it by 800. If you put it in your calculator just as you see it, you shouldn't have any problems. But you'll notice in this line right here that it was really important that you wrap that up in parentheses, that exponent, and wrap this up in parentheses, and do not distribute the 800 in before it's time. And now in our last examples, we'll look at one problem and look at all the different methods that we have in front of us. And we can see that in the first one, simple interest, we're going to take the principal and add the interest. And again, we can use that other formula as we mentioned. The amount earned is going to equal 1,000. That's the principal times 1 plus rate times time. And the rate is 8%, and the time is 10 years. Get that? Here we go. So this will be equal to rate, which is 0.08, times 10. And when you work what's inside here first, you're going to get 1.8 times 1,000, which gives us $1,800. So that's what simple interest will give us. Next, we have yearly. We're going to compound it yearly. So we will use the compound interest formula. I know it's a little bit fuzzy here, but follow along here. The principal is 1,000. 1 plus 0.08 divided by 1, raised to the 1 times 10 power. And that gives us, when you put that into your calculator, this makes a significant difference right here. You can see what we're talking about from the last example, $2,158.92. And again, that's pretty significant between those two. When it's compounded quarterly, again, you're going to use the same formula as you did here for compound interest, and then down here, compound continuously. What I'd like for you to do is to work through these problems and see what you get, and we'll talk about it in class. Thanks, and we'll see you tomorrow.